PVC example on EKS. Okay, so here some new concepts we'll be learning. Okay, so here we'll be creating a policy. Okay, we'll attach that policy, then we'll create a role. Okay, means we are creating two roles. One is for attaching this policy to something I'll explain, and then one more account will be creating service account. Okay, and for that also we'll be creating an IAM role. Then will this CSI, you remember about CSI, container storage interface. Okay, so we'll be using a driver, okay, for EBS volume. So by default the volumes which we'll be creating using EBS, they won't be attached automatically. For that we'll need a driver, so that driver also will deploy. Then we'll deploy an application which will ask for a PVC. Okay, and all the data will be stored on that PVC. Okay, so we'll be creating an IAM policy. Here I've referred configure an IAM policy. Okay, so why we require that policy? Grant permission to manage and interact with EBS. One of the policy will define that all the permissions required for interacting with the EBS. Okay, and one role we'll be creating. Okay, that will allow the EBS driver to operate with AWS. Even the driver which will be created, that needs a role to interact. Then we will be creating one service account. The service account is not part of a AWS, it is a part of a Kubernetes. Okay, so EBS CBS driver operates with Kubernetes cluster, so it needs a service to interact with the Kubernetes. Okay, so and that service account is also mapped to AWS role, so that EBS driver have required permissions, AWS permissions. Okay, now there is also an OIDC provider that will be using. It will be used for secure and scalable authentication between Kubernetes and IAM. So if you see, just for creating a dynamically volume, so many permissions are required. So Kubernetes cannot directly use IAM roles. Okay, that's why the combination of OIDC and service account is required. Okay, the service account will be created on the Kubernetes cluster for using a service of AWS. That's why it's called a service account. So the service account will be created on Kubernetes cluster, and we'll be also having an EBS CSI driver. Okay, we'll create that. It's used for providing dynamically the pods volumes to the pod. Okay, so let's start it. So we are first creating an IAM policy. Okay, so we'll be just exporting some variables. So our cluster is ready. kubectl get nodes. So I have modified the script, or you can say the command. So this is the command, create.sh. So instead of two nodes, I'm taking only one node. Okay, only for demo purpose we needed two nodes. Okay, but now everything I have changed to one node. So now onwards we'll be working only on one node. Okay, that will save some cost. kubectl get nodes -o wide. So we have only one node. Okay, kubectl get all. It is a fresh installation, so nothing is scheduled. Okay, on this node, no pods are there. We'll just export this okay, variables. So if you do echo $EBS CSI policy name. Okay, so this is the policy name which we have set, and we have also set. So as we will be using it multiple times, so that's why we have set it as a variable, and we'll use it in the next commands. So policy name which we'll be creating is Amazon EBS CSI driver, and our region will be US East 1. Now we'll create this policy JSON. Okay, so instead of doing everything from GUI, we are doing it via command line. In that, we are defining some policy. In short, the permissions. Let's create this file. So in this file, we are giving various permissions. Okay. So if you see, it has permission to create a snapshot, attach volume, detach volume, okay, describe tags. Similarly, it will have create volume, create snapshot, okay, then delete tags. So various volume related permissions we have defined in this JSON policy. So we have defined a policy. Now let's create it using that file. We'll create a policy, IAM policy. So this is the command. We are using the same file which we created now. So create a policy in the region, AWS region variable we are using here, US East 1. The policy name also we are using as an environmental as a variable, and we are using this file, above file, to create that role. So for creating this lab, I used it, okay, and I didn't delete it, so it is already available, that policy. Now let's create. So let me first export it and then I'll explain. So what these two commands do. So if you see in this variable, okay, EBS CSI policy, Amazon resource name, ARN stands for Amazon resource name. Okay, so we need a name, okay, for that particular policy, and its name is, and then we output it on the screen, and the name is this one. Okay, so this is the name for complete. So it has account number. This is our account number and the policy name. That's what we exported. We'll need that. Now we'll have to list the IAM roles related to, just export, create policy. Okay, let's see. So if you see, if we list the roles, okay, we'll get some role EKS related. Okay, this will need in the next step attaching it to the policy which we created now. Okay, so this is done now. I just took this one. Okay. You also remember this, that when you list the roles, you use the correct one. So here, this is the correct one. Earlier I was using something different, okay, which I just copy pasted. Now the policy is attached. We can verify the attached policy. Okay. Again, the same thing. We'll have to use the correct name here. The role name is this one. So if you see, we can list the roles with the policies. Now we need to configure IAM role for a service account. Okay, so just use the same EKSCTL associate. So OIDC provider will need because it cannot directly communicate. The EKS cannot communicate directly with the AWS, so we are using the OIDC provider. Okay. Now again we'll need a service account, so that the service account will interact with the IAM. So we are creating an IAM service account using EKS CTL itself. It will take some time. Okay, it's done. Now it's time to install the driver. So if you see here, kubectl get namespace. Okay, and we should always check whether driver is already there or not. We need to check it in a kube system. kubectl-n kube system get all. So if you see, there is nothing related to EBS here. You can grab it if you want. Grab EBS. Okay, so we do not have anything related to it. So when we install the drivers using the commands which I'm showing next, we'll see it in as a pod here as a driver. Okay, so let's copy this repository, Helm repo. Okay, so it's already there. The repo is already there. We can search for the driver in that repository. So we have this driver in the repository. We need to install it. Let's check if we already have this. Okay, the repository is already there, but we need to install the driver. In kube system, we'll again check if the Helm chart is installed or not. We just check the repository, not the Helm chart. So in kube system, we do not have EBS installed. Now using this command, we'll be installing it, the driver. So here what we are mentioning, that we are installing a driver, okay, and we need volume scheduling true, volume resizing true, volume snapshot true. Okay, which account to use, this one, which service account to use, this one which we created above. Okay, controller name also the same. So some definitions we have came to the Helm charts. Now if we see Helm ls EBS, we have this chart installed, and even in the kube system we can see that few pods will be running which will act as a driver. Okay, so we have a deployment, daemon set, replica set, and even the pods are running, and all are running properly. Okay, so our installation of EBS CSI controller is done. In short, the driver is installed. kubectl get storage class, okay, will give you if there is any already defined storage class in it. Okay, so if you see, by default there will be always one GP2, okay, name of the storage class, and the provisioner is AWS EBS itself. Okay, so this one is already created by default. If you want to get its value, so this is one of the trick. Okay, this is also created internally using some YML files, and we can also output it on the screen. Okay, So we just need to get it and output -o as a YML file. So if we see, so when we create YML file, we do not use all the options. Okay, so in case we need to recreate any file, this is one of the method. Okay, output it as a YML file on the screen, copy it, and means not everything we required. This it maintains automatically 274 and all. But I wanted to show you that by default it is also a YML file. So the storage class name is GP2, and which provisioner it is using, AWS EBS. So in case this file is not there, we'll have to create it. Okay, but the default installation will always have this storage class. So we'll be using the same storage class because we are also using AWS volume. Till now we were not having the drivers. Now even the drivers we have. Okay, so now it will allow us to create a PVC. So using kubectl get storage class complete, you can write, or you can just write shortcut like this. Okay, and the storage class is already there. Let's see if there is already a PVC. There is no PVC in a default namespace. Let's also check for the PV. Okay, now we'll be creating one deployment which will use the PVC. So I'm creating an HTTPD deployment. So if you already have such file, it will just overwrite it. And if you do not want to overwrite it, then rename it or create this in a separate folder. So here we are just creating a simple deployment.yml for HTTPD service. Okay. And here we are saying that get first we'll create a persistent volume claim PVC. Okay, rather than creating 3 different files, I've included everything in the same file with this separator. Okay. So here I'm saying that get a persistent volume, okay, from storage class GP2. Okay, and I need 1 gig of storage. If possible, naming PVC, that create HTTPD PVC of 1 gig and use the storage class. If the storage class, this kubectl get storage class is not there, okay, already configured, then this block will not work. Okay, so we need to make sure that this name matches here. Okay, in case you are on a different cluster, on a different cloud, the storage class will have to define separately. Always check if there is any default one and try to use it. Here we are using GP2. The storage persistent volume is created PVC. Now we are here defining it as a volume. Okay, we need to define it. The name is HTML. Okay, and we are using HTTPD PVC claim. So in short, it is named as HTML, and this is mounted. This volume which is defined here, which is nothing but this PVC, is now mounted on USR local Apache htdoc. This is the default HTML page which we get when the HTTPD is installed. Okay, so all our pages will be stored indirectly in that PVC. Okay, and we have defined a cluster IP service. Let's again check storage class. We have checked. We have the storage class GP2 PVC. So GP2 is one of the EBS volume types. That's why it is called GP2. There is also GP3 as well, which has better performance. So we do not have PVC. We do not have PV. Okay, let's apply this HTTPD deployment .yml. We have to add -f. So the persistent volume is created. Okay, the deployment is created, and even the service is created. Let's check kubectl get all. Okay, so if you see that container is creating or running, that means your PVC is properly configured, the driver is properly configured. If you see it in the pending state, that means something is wrong. Okay, let's check. Now the pod is running properly. Let's see the storage class, it's the same. Now if you see PVC, okay, it got automatically 1 gig of persistent volume. Okay, automatically from EBS, we will see it in the console now, and PV. Okay, so we directly called for PVC, but it create the PVC at the backend automatically, and from that PV physical volume, it gave us 1 gig. Okay, so this is how the PVC works. Okay, so I know it is a bit difficult. Even I found very difficult to prepare this exercise because the documentation is not properly given. So by following various documentation, I created this single one. Even the documentation for EKS is not sufficient. So this will be useful for you always. Okay. And some more things are left. So let's first go to our AWS console and check for volumes. There will be some volumes which I created yesterday as well. Let's check that. So when we go to volumes, on storage gateway volume, we need EC2 volumes. Okay, so the EC2 feature you check. So if you see, this is the one which is created today. So this is the one created for EKS and all, but the 1 gig which we asked for, it created automatically. Okay, so this is very useful. Okay. So in production, otherwise, if you do not have this automation, you'll have to go to volume, create a volume. From this volume, create a PV. Okay, for PV, we'll have to write a different definition. Here we have written directly PVC. Then after writing a definition for PV, we'll have to write a definition for PVC. Okay, so it's better to use the dynamic one. So if you see here also, one example is given, the storage class, in case we have to create it from scratch. Okay, the storage class name. Okay, and if you see here, the PV is created, persistent volume. Here we'll have to give the volume ID when we create it. Okay, so this is the one of the volume ID. When we create using create volume, that we'll have to use. Okay, and then we'll have to claim from this fast. I gave it a name, fast storage. Okay, for example, you don't perform it. This is only for an example. Then from here we are saying it has a PV of 10 GB. Ask her, give me 5 gig of PVC from here. Okay, so to avoid this manual task, we need to use the dynamic one. So it is manual provisioning is given here. Okay, the dynamic one which we have done now. So now let's check the PV is attached. Now let's get kubectl get all, or you can also do kubectl get pods directly. Kubectl get pods. We do kubectl exec. So we can use load balancer and test it, but load balancers are costly. So let's test it by going inside the pod itself. Kubectl exec -it pod --bin bash. We are attaching a shell going inside the pod now, and curl for the cluster IP. Or we can also do curl localhost because it is the same pod on which HTTPD service is running. So let's install it. apt get update. -y install curl. Now if I do curl localhost, if you see, it is not giving the proper page. Okay, it is just giving the directory structure. This is not what we want. And why? Because if you see mount command, mount grep nginx, I think, or just try with html. Okay, so I think it will give it in a df -h grep nginx. Let's check that. Okay, we have to use Apache, not Nginx. So if you do df-h grep Apache 2, the volume is mounted. So the volume which we created, it is mounted on this directory. Let's go inside this directory and do ls. If you see, it is just a empty 1 gig of PVC which we got. It doesn't have anything. Okay, and it checks for this directory httpd by default for displaying the page. Now if I write cat index.html, in that volume it will be stored and it will be there forever until that volume is deleted from the AWS. This is my test tab. Control D. Now if I do curl localhost, it will show me the page. So in short, I just wanted to show that by default the volume which we attach is empty. Okay. So this was all about the PVC. Now even if we delete this pod, okay, the PVC will not be deleted.